Welcome to math classes. In this video, we will learn about the NCERT class 12th chapter 7, that is integrals. Okay, so integrals is a very big chapter in NCERT class 12th book. So I split it into two parts. In this video, we will concentrate only on indefinite integrals. We will learn up to indefinite integrals, and the rest will come in the second part. Okay, so let's get into this one. This is one of the most important chapters for the class 12th, as well as students who are preparing for JEE, BITSET, or any other engineering entrance. This is the one of the most important chapters, so don't miss it. All the practice problems you have to do to brush up your integration basics. Okay, yeah. First, let us understand the definition of integration. Okay, integration refers to the process of combining separate distinct parts or elements into unified functional whole. Okay, which itself is telling that it is a summation. Okay, that is very important fact to understand about the integration. Okay, it is process of combining separate distinct parts or elements into unified functional whole. Okay, that's the definition of integration. And maths definition is integration is process of calculating the total size, volume, area under a curve, or by summing small parts, often considered as reverse process of differentiation. Okay, so noted by this one, integration of f of x dx is equal to, this is how we notation, I will explain the notation later, is equal to g of x plus c. This implies, okay, if I differentiate here both sides, okay, if I differentiate both sides, I get f of x here, and this is nothing but differentiation of g of x plus c. C is a constant, so you will anyway get 0 with respect to x. Okay, which is equal to f of x. That's the integration definition by mathematics. Okay, now indefinite integrals. Out of this, indefinite integral is the family of all antiderivatives of f of x is called indefinite integrals, which means integration of f of x ds equal to capital F of x, some other function basically, plus c. Okay, indefinite integrations do not have any limits. Okay, they don't have, because it will change with respect to the value c. Okay, it represents a family of curves. When you change c value, you will get a different curve. Okay, family of curves, correct? So plus c is a constant term, addition is compulsory. Okay, because this is how it is defined. Okay, if I differentiate on RHS side, okay, whether I have a constant or not, okay, it still gives a same value as f of x, small f of x, correct? So whenever you do integration, you actually get integration value plus some constant term. Okay, this we should not forget. Okay, then the value of constant term defines the family of antiderivatives, which means by changing this value of c, I get a different curves. Okay, suppose example, if I take, let's say f of x is capital F of x is x square. Okay, then plus c. Okay, by varying the value of c, I get curves like this. Okay, all looks similar. Okay, but they are shifted in the x-axis, in the y-axis. Okay, there will be a shift on the curve. This is the difference of difference this constant term makes actually. That's why we call it family of curves or family of functions. Okay, so family of curves of f of x, which is equal to, which is x square plus c in this case. Okay, this is how it looks. Okay, hope you understand the basic definition of integration. We do integration by several means. Easiest and one of the most used method is observe integration. Okay, find out what is the differentiation and then how you can basically do the reverse. That is one of the most important thing. Okay, so let's understand the terminology. If I write integration of f of x dx, which means integral of f with respect to x, that is the meaning. Okay, in this one, f of x is called integrand, x is called variable of integration. Okay, to integrate means to find the integral of, an integral of f means a function f such that f dash x equal to f of x. Okay, integration is process of finding the integral. Constant of integration is any real number c considered as a constant function. Okay, or term. Okay, so these are the definitions or terminology of the integration. Okay, next, some important integrals we have to remember. Okay, this is nothing but inverse of differentiation, so you have to remember this, otherwise it is very it will be very time consuming for you to solve all the integrals. Okay, suppose, okay, differentiation of x to the power of n plus 1 by n plus 1 is nothing but I get n plus 1 into x to the power of n divided by n plus 1, so which is x to the power of n. correct? Now the reverse is, if I take differentiation to the other side, I can call it integration. So integration of x to the power of n dx is nothing but x to the power of n plus 1 divided by n plus 1 plus c. Note down, n is not equal to minus 1. Okay, when n equal to minus 1, it's a different value. You get 1 by x, basically log x, that is. Okay, when n equal to minus 1, this is nothing but integration of 1 by x, which is log x. How you get it? Differentiation of log x, we know with respect to x is 1 by x. So if I take reverse, integration of 1 by x dx equal to log x plus c. Okay, so similarly you can note down all these things. Integration of cos x is sin x plus c. Integration of sin x with respect to x is minus cos x plus c. Integration of secant x tan x dx is nothing but secant x plus c. Integration of 1 by square root of 1 by x, 1 minus x square dx is sin inverse of x plus c. Okay, or you can also say minus cos inverse of x plus c. Both are same basically. Okay, because differentiation of sin inverse of x is 1 by square root of 1 minus x square. Differentiation of minus cos inverse of x is nothing but 1 by same, basically 1 by square root of 1 minus x square. So you will get same values. Okay, next. Yeah, some more important properties of integration, just like differentiation. Differentiation of integration of f of x dx by with respect to dx is f of x. Okay, integration of d of differentiation of f of x by dx is nothing but f of x plus c. Integration of f of x plus gx with respect to x is integration of f of x with respect to x plus integration of g of x with respect to x. This is very important one to note. Okay, and this one. Okay, integration of constant k into g of x with respect to x is constant into integration of g of x with respect to dx. Okay, so once you know this one, let's get into practice problems. Integration is mostly it's all about practice. Okay, you practice more and more problems actually. As many as you see, uh, anywhere you see a function, okay, try to differentiate, integrate and differentiate and see what will be the values. Okay, that is how you will master the integration and differentiation. Okay, so first exercise we will do only by observation how you can do integration. Okay, so this is the chapter 1, sorry, exercise 1. We will do only by observation in this. Okay, so first is sine 2x. Okay, so you have to close your eyes and think when you will get sine 2x in the differentiation. When you differentiate cos 2x, you will get sine 2x and something else also. Correct? So differentiation of cos 2x with respect to x is minus 2 sine 2x. Correct? You will get cos 2x differentiation is sine 2x and 2x differentiation is, sorry, minus sine 2x and 2x differentiation is 2. So minus 2 sine 2x. Now you rewrite this expression. Differentiation of minus cos 2x with respect to x is 2 sine 2x. Correct? So integration of sine 2x dx is nothing but minus cos 2x divided by 2 plus c. Okay. Hope you understand how to do the integration by observation or inspection. Okay. So always do a proper differentiation first. Okay, don't try to adjust here directly. Okay, all these constants and all you can adjust later. This is very important. Okay, so yeah, next cos 3x. So when you will get cos 3x in differentiation of sine 3x with respect to x is 3 cos 3x. So 1 by 3 differentiation of sine 3x by dx is cos 3x. Now you do the reverse. Integration of cos 3x is sine 3x by 3 plus c. Okay. Uh, Integration of e to the power of 2x. Okay, differentiation of e to the power of 2x is 2 e to the power of 2x. So integration of e to the power of 2x is e to the power of 2x divided by 2 plus c. Okay, integration of ax plus b whole square. Okay, so when you will get ax plus b whole square in differentiation, when it is cube. Correct. So differentiation of ax plus b whole cube is nothing but 3 times a times ax plus b whole square. Now this is what I am interested, right? So integration of ax plus b whole square with respect to x is nothing but ax plus b whole cube divided by 3a plus c. Okay. Now here it is the integration you will do by parts, right? First integration of sine 2x minus integration of 4 times e to the power of 3x. Correct? So integration of sine 2x is nothing but minus cos 2x by 2. Integration of e to the power of 3x is minus 4, and integration of e to the power of 3x is e to the power of 3x by 3 plus c. Okay. Similarly, this one, okay, you can do it yourself. By observation, you can do it. There is only one thing. The constant integration of 1 is nothing but x. because this is x power 0, so you will get x. Okay, next. Yeah, here you multiply it. Okay, integration of x square into 1 minus 1 by x square. So if I multiply the expression, it will become x square minus 1. Okay, integration of x square minus 1. Now I will do it by parts. Integration of x square dx minus integration of 1 dx, which is nothing but x cube by 3 minus x plus c. Okay, next. Integration of ax square plus bx plus c. So I will apply integration by for each part. Okay, which is nothing but ax cube by 3 plus bx square by 2 plus cx plus k constant. Okay, integration of 2x square plus ex. Again I will apply integration to each part. Okay, integration of 2x square is nothing but 2x cube by 3. Integration of e to the power of x is e to the power of x plus c. Okay, next. This is also, it's a whole square, right? Square root of x minus 1 by square root of x whole square, which is nothing but x plus 1 by x minus 2. Now I will apply integration to each term separately. Integration of x is x square by 2. Integration of 1 by x is log absolute x. Integration of minus 2 minus integration of 2 is nothing but minus 2x plus c. Okay, now here integration of x cube minus 5x square minus 4 by x square. If I divide this with x square, I'll get x minus 5 minus 4 by x square. Now I can do integration of each part. Okay, so that is nothing but x square by 2 minus 5x plus 4 by x plus c. Okay, same as above. Okay, I first write it into x to the power of some n and then apply individually. Okay, this is the answer. Next. Okay, so same here I need to do simplification. So x cube minus x square plus x minus 1, I can write it as numerator, I can write it as x square into x minus 1 plus x minus 1 or x minus 1 into x square plus 1. So x minus 1 and x minus 1 in the denominator gets cancelled. I am left with x square plus 1. So I will apply the integration for each one. Integration of x square plus 1 is integration of x square plus integration of 1, which is x cube by 3 plus x plus c. Okay, so this is again same. You multiply x to the power of half with each of the terms. So you will get integration of x to the power of half minus x to the power of 3 by 2 with respect to x, which is nothing but 2 by 3 x to the power of 3 by 2 plus 2 by 5 into x to the power of 5 by 2 plus c. Okay, next. Again, same thing. It is just you have a quadratic equation multiplied with square root of x. So you first write what is the x power in each term properly and then apply integration for each part. Okay, this is the answer, you'll get it. Again, similar one, you need to apply integration for each part. Integration of 2x minus 3 times integration of cos x plus integration of 2 e to the power of x, which is nothing but x square minus 3 sin x plus e to the power of x plus c. Okay, this is also exactly same as above. You can do it yourself. Okay, you have to solve every problem, otherwise you will not get practice. Okay, go from easy, start with easy ones and then go into very complex. You can actually go into very complex integrations in JEE or BITSAT level. Okay, integration of secant x into secant x plus tan x. So I can write if I multiply this secant x, if I take inside bracket, it will become secant square x plus secant x plus tan x. Now I will apply individually integration of secant square x with respect to x plus integration of, there is an integration missing, integration of secant x tan x dx. Okay, so integration of this one secant square x is tan x, integration of secant x tan x is nothing but secant x plus c. Okay, so this is also same, secant square x by cosecant square x, which I can write it as tan square x, nothing but tan square x, which I will rewrite it as secant square x minus 1. So my integration is nothing but integration of secant square x minus 1 with respect to x, which is tan x minus x plus c. Okay, so this is also same. You will simplify this. 2 minus 3 sin x by cos square x is nothing but 2 secant square x minus 3 secant square x tan x. Now if I apply integration to individual term, it will become 2 tan x minus 3 secant x plus c. Next. Yeah. What is the antiderivative of this? Antiderivative is nothing but integration of this one. Okay, which is very simple, straightforward. This is the integration of x to the power of half plus x to the power of minus half, which is 2 by 3 x to the power of 3 by 2 plus 2 times x to the power of 1 by 2 plus c. Okay, now integration of if d of f of x by dx equal to 4x cube minus 3 by x to the power of 4 such that f of 2 equal to 0, then what is f of x? Okay. So this is differentiation of this one is this value. So I need to get f of x. What is my f of x? F of x is nothing but integration of this value. Correct? F of x is equal to integration of 4x cube minus 3 by x to the power of 4 with respect to x, which is nothing but x to the power of 4 plus 1 by x cube plus c. Okay, so this is my f of x. Now what is given? F of 2 is given. So f of 2, if I substitute 2 to the power of 4 by 1 by 2 cube plus c, which is equal to 0, which implies c is nothing but minus 129 divided by 8. Okay, minus 129 by 8. So what is my f of x? F of x is nothing but x to the power of 4 plus 1 by x cube minus 129 by 8. Okay, this is how you derive your f of x in integration. Okay, how to find the constant term? Okay, from the one of the given value you substitute and you will get the constant term. Okay, this is how you do. Okay, next.
Struggling with Maths Olympiad or Engineering Entrance Prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full NCERT classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/PSK99999 and let's make math your strength.
Let's understand the methods of integration. As of now, we learned only integration by observation. Okay, that is the reverse derivation. So we understand the derivation and then from there we just do a reverse operation. Okay, that is by observation. Now let's understand the other methods. Okay, there are three other methods mainly. There are many more actually, but these are the three mainly. Integration by substitution, integration using partial fractions, integration by parts. Okay, let us learn these one by one in this indefinite integrals. Okay, so right now in this slide we will understand integration by substitution, then do some exercise problems on this one, then go to the next one. Okay, so integration by substitution is simple. Okay, let's consider I equal to integration of f of x dx. Then if you take x as g of t, okay, then dx will become g dash t dt. Okay, so my I is nothing but integration of fx dx, which will become integration of f of gt, f of g of t into g dash t into dt. Okay, so this is how we do. Okay, if you don't understand this exactly, if it is in this form, I can actually convert it to this form, right? And this form is very simplified form compared to this one, right? So that is what integration by substitution. Okay, if I take g of t as x, okay, then g dash t dt will become dx. So this is nothing but f of x dx. So if integration is given in this form, I will convert into this form. Okay, let's see how to do that. One example. Okay, consider I equal to sine of mx dx. Okay, now we know that differentiation of m of x is nothing but m and dx. Okay, so let mx equal to t. Okay, d of m of m times differentiation of x is nothing but differentiation of t, d of t. So my I is nothing but sine t, because mx is nothing but t, sine t dt by m. Okay, 1 by m is constant, so I'm taking it out. 1 by m integration of sine t dt. Now this is simple. This I know. Okay, this is nothing but minus cos t. Okay, minus 1 by m cos t, right, plus c. And now t is, I will replace it back to mx, so it will become minus 1 by m cos mx plus c. So remember one thing, any standard integration, basically standard integration like this, where you have coefficient of x, then it will go into the denominator. Okay, so if it is integration of ax plus b, then it will be integration of ax plus b whole square by 2 into a it will become. Okay, a will come, coefficient of x will come into the denominator. Okay, hope you understand this one. This is how we actually use the integration by substitution method. Okay, let's choose one more example. Okay, consider I equal to sine of tan inverse of x by 1 plus x squared dx. So if you look at this one, it looks so complex, correct? It looks so complex that we will be thinking how to do. Now we'll choose the substitution method. See, I have tan inverse of x here. So differentiation of tan inverse of x, I know that it is 1 by x square, correct? So I will take differentiation of this value tan inverse of x as t. Okay, then my dt is nothing but dx by 1 plus x square, correct? Differentiation of x into tan inverse of x differentiation is 1 by x square. Now I will replace it. Now my I is nothing but this is t, because tan inverse of x is t. So sin t and dx by 1 plus x square is nothing but dt. So dt. This is nothing but integration of sin t dt, which is minus cos t. Now I will replace t. So minus cos of tan inverse of x plus c. Okay. Hope you understand such a complex integration by substitution method. We simply did it just using integration of sin t dt. That's it. Okay. And one more thing, yeah. If you see previously, I gave some standard integrations actually, integrals to remember. In that, integration of tan x is not mentioned. That's because you need to understand this method, how to get it. Okay. So if you remember how to get it, then you don't need to remember all the formula actually. Okay. Some of them you can very quickly you can derive yourself. So integration of tan x is nothing but integration of sin x by cos x dx. Now let's take cos x as t, then minus sin x dx is dt. Okay, so now my integration will become integration of minus dt by t, which is nothing but minus log absolute t plus c. Now t is nothing but cos x, so it will become minus log absolute cos x. Or you can write it as, you can also write it as, if I take minus as power of this one cos x inverse, then it will become secant x. So log of secant x plus c, integration of tan x is. Or I can use if this is useful anywhere. Okay. So now similarly, integration of cot x is nothing but log of sin x, log of absolute sin x plus c, or minus log of secant x plus c. Okay. So remember this formula. If you don't remember, you can quickly derive it, but you should know the method what you are using. Okay. So that is important. Okay, next. Yeah, let's do the exercise 7.2 and then understand the substitution method completely. Okay. First one, 2x by 1 plus x square. Okay, very clear. Okay, if I do x square differentiation, I get 2x. So either I can take x square as t, or constant term doesn't make any difference in differentiation, correct? So I will take 1 plus x square equal to t, which means 2x dx by dt equal to 1, obviously. Okay, with respect to 2, I am differentiating. That's why I get dt to the other side. So 2x dx equal to dt. Okay, every time I will not write like this. Okay, I will just write 2x dx equal to dt. Okay, now I will substitute. Now 2x integration of 2x dx by 1 plus x square is nothing but 2x dx is dt. 1 plus 1 by 1 plus x square is, or 1 plus x square is t, so it is 1 by t. Now this is nothing but log absolute t plus c. So this is nothing but log of 1 absolute 1 plus x square plus c. Okay, next, log x whole square by x. Okay, now we know that log x differentiation is 1 by x. So take log x equal to t. So 1 by x dx equal to dt, or integration of log x whole square by x dx is nothing but integration of t square by dt. Because this log x is t square, 1 by x dx is dt. This is nothing but t cube by 3 plus c, constant. So that is nothing but log x whole cube by 3 plus c. Okay, next. 1 by x plus x log x. Okay, this is also similar to the above one. I take x common basically. Okay, then it will become 1 plus log x. And 1 plus log x, if I take it as t, then 1 by x dx is dt. Okay, because 1 is anyway differentiation is 0. So log x differentiation is 1 by x. 1 by x dx is dt. Now I will go to the integration. Integration of 1 by x times, I take x common. X times 1 plus log x equal to dx, which is nothing but integration of dt by t, that is log of absolute t plus constant. So t is nothing but 1 plus log x. So log of 1 plus log x equal to plus c. This is the integration. Okay, next. Sin x, sin of cos x. Okay, here I take cos x, which is inside as t. Then it will sin x dx will become dt. correct? And minus sign is there, so I'll take care of minus sign. So sin x, sin of cos x dx is nothing but minus sin t dt, which is nothing but cos t plus constant. So cos t is nothing but cos of cos x plus constant. Next, sin of ax plus b, cos of ax plus b. Okay, now first thing is use trigonometry, simple trigonometry to convert into a simple sign, correct? Sin a cos a is nothing but sin 2a by 2. That is what I used here. So sin of 2 times ax plus b by 2. Now 2 times ax plus b, if I take it as t, okay, then 2a dx equal to dt. So if I replace it here, this will become 1 by 2 sin t dt by 2a, okay, which is nothing but 1 by 4a sin t dt, okay, that is nothing but 1 by 4a minus cos t, okay, into minus cos t or minus cos t by 4a plus constant term. Now t I will replace it back, so minus cos of 2ax plus 2b divided by 4a plus constant. Square root of ax plus b. So here instead of substitution, you remember this one, we already know integration of x to the power of n is nothing but x to the power of n plus 1 by n plus 1, where n is not equal to 1. So similarly, okay, any of such types, okay, it need not be square root, it can be any of the power, okay. Integration of ax plus b whole to the power of n is nothing but ax plus b whole to the power of n plus 1 divided by n plus 1, but since x has a coefficient a, it will come in denominator, okay. So this is, remember this, you apply this one, you will get the answer, okay, simple. No. X into square root of x plus 2. Okay, so this I will write it as, simply I'm splitting this actually into x plus 2 terms. Okay, so x plus 2 minus 2 I can write into square root of x plus 2, which is nothing but x plus 2 whole to the power of half, this is x plus 2 whole to the power of 1, this is, so it will become x plus 2 whole to the power of 3 by 2 minus 2 times square root of x plus 2. Okay, now if I apply integration individually, this is very simple, same as I apply this rule actually. Okay, so integration of x plus 2 whole to the power of 3 by 2 is nothing but x plus 2 whole to the power of 3 by 2 plus 1, that is 5 by 2 divided by 5 by 2 minus 2 times x plus 2 whole to the power of 3 by 2 divided by 3 by 2. Okay, now simplification, you get this answer. Okay, hope you understand how to apply this one. Okay, this is very important, and I mean default integration formula, so you should remember this. Next, x into square root of 1 plus x square. We know that 1 plus x square, if I differentiate, I get x term. Okay, correct, 2x. So I take 1 plus x square as t, 2x dx is dt, or x dx equal to dt by 2. So my integration will become half 2x into 2x into 1 plus x square whole to the power of, sorry, there is no 2x actually, we should remove this. This is x into, okay, half into 2x into 1 plus x square whole to the power of half dx, correct? The half and 2 gets cancelled. Now this I will rewrite this as half into 2x dx is dt, and this is nothing but t to the power of half. So what I will get is half into t to the power of 3 by 2 by 3 by 2. So 2 and 2 gets cancelled. So I am left with 1 by 3 into t to the power of 3 by 2, which is nothing but 1 plus x square whole power 3 by 2 plus c. Okay. 4x plus 2 into square root of x square plus x plus 1. Now, if I differentiate this one, I get 2x plus 1. So, there is a 2x plus 1 here, right? 2 into 2x plus 1 this is. So, that's what I did. Let x square plus x plus 1 is t. So, 2x plus 1 dx equal to dt. So, my integration will become 2 times 2x plus 1 into square root of this value, which is nothing but 2 times t to the power of half dx, which is nothing but half into t to the power of 3 by 2 by 3 by 2, which is nothing but 1 by 3 into 1 plus x square whole to the power of 3 by 2 plus constant. Okay, 1 by x minus square root of x. Now if I take square root of x common, okay, this will become square root of x minus 1, correct? I can do that way, or simply you call this one square root of x as t, then x is nothing but t square, x is t square. So dx is nothing but 2t dt, correct? Now you remember this one, dx equal to 2t dt, and replace carefully. Okay, now integration of 1 by x minus square root of x dx is nothing but square root of dx is 2t dt, so I wrote 2t dt, and x minus square root of x is nothing but t square minus t. Now if I cancel t's, I am left with 2 times integration of dt by t minus. This is nothing but 1 by x form, correct? Integration of 1 by x form, which is 2 is there. So 2 times log of absolute t minus 1 plus constant, which is 2 times log of absolute square root of x minus 1 plus c. Okay. Now, x divided by square root of x plus 4. Okay. Now again, I will take simply square root of x plus 4 as t. So x plus 4 is t square. So dx equal to 2t dt. Now I'll replace the terms. So integration of x by square root of x plus 4 will become integration of x is nothing but t square minus 4. Okay. And this is t. So into dx is nothing but 2t dt. So t and t gets cancelled. I am left with 2 times integration of t square minus 4 dt, which is very simple, which is 2 times t cube by 3 minus 8 times t plus constant. So if I replace t with the square root of x plus 4, this is what the answer is. Okay, next. Yeah, x cube minus 1 whole to the power of 1 by 3 into x to the power of 5. Okay, now this one, see, if I integrate x cube, basically, if I integrate x cube minus 1, I get 3x square term, correct? So I can take x square out, I am left with x cube, so which I can again replace with whatever t, correct? So that's how you should decide what you should take for as t. So x cube minus 1 is t. So 3x square dx is nothing but dt. So my x cube minus 1 whole to the power of 1 by 3 into x to the power of 5 will become, okay, this is nothing but t, I already know. So t to the power of 1 by 3 into x cube into x square. Okay. So t to the power of 1 by 3 into t plus 1, x cube is nothing but t plus 1. Okay, into x square. I'll leave the x square as is because x square dx I can replace with the dt, correct? So my integration will become t to the power of 1 by 3 into t plus 1 into x square dx. Okay, and x square dx is nothing but dt by 3. So I'll take integration of t to the power of 1 by 3 plus into t plus 1 dt by 3. This is if I take t to the power of 1 by 3 inside, it will become integration of t to the power of 4 by 3 plus t to the power of 1 by 3 dt divided by 3. This is constant anyway, pull it out, and inside one you can carefully do the integration. What you will get is x minus 1 whole to the power of 7 by 3 by 7 plus x minus 1 whole to the power of 4 by 3 by 4 plus c. Okay, next. X square divided by 2 plus 3x cube whole cube. Okay, now I'll take the x cube term is there, x square is here. So if I take this as t, then I'll get x square will go into the x square dx will go into the dt, correct? So this one we have done before, so you can just look at it and do it yourself. Okay, 1 by x log x whole to the power of m. All these problems is same. Don't worry about the power actually. Take log x as t, then 1 by x dx is dt. So I will replace the, this is nothing but integration of dt by t to the power of m, which is t to the power of minus m plus 1 divided by minus m plus 1 plus c. Okay, where it is nothing but log x whole to the power of minus m plus 1 divided by minus m plus 1 plus constant. Okay, next. Integration of x by 9 minus 2x square. Okay, this is simple. This is 3 square, this is 2x whole square. So 2x you take as 9 minus 4x square, you take it as t. Then you get minus 8x dx. So numerator x and dx you are covering basically, right? Equal to dt. So this I can rewrite this as minus dt by 8t, which is nothing but minus 1 by 8 log absolute t plus constant. Okay, t is nothing but 9 minus 4x square. This is what initially you took, so replace it. Next. Yeah, this is a straightforward one. E to the power of x integration is e to the power of x, but you have e to the power of 2x plus 3. Okay, so which means the coefficient of x you should divide, correct? So e to the power of ax plus b divided by a. So the answer is e to the power of 2x plus 3 divided by 2. Okay. E to the power of tan inverse x divided by 1 plus x square. We know that if you take tan inverse x as t, then dt is nothing but dx by 1 plus x square, right? So this is as simple as e to the power of t dt, which is nothing but e to the power of t plus constant. T is nothing but tan inverse x, so e to the power of tan inverse x plus c. Yeah, x by e to the power of x square, very simple. If you take x square as t, then you get 2x dx as dt. So this is as simple as substituting numerator with dt and denominator with e to the power of t. Okay, 1 by 2 you will get because you get a 2 here. Okay, so that's next. Yeah, e to the power of 2x minus 1 divided by e to the power of 2x plus 1. Okay, so you can do it different ways. Okay, you can take e to the power of 2x plus 1 as t and then solve it, but there is another simple way. Okay, this you can rewrite this as e to the power of 2x minus 1 divided by e to the power of 2x plus 1. You can rewrite this as e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x. Okay, so now this is the integration. Now if I take this denominator as a t, okay, then numerator into dx is my dt. Okay, e to the power of x plus e to the power of minus x is t, then e to the power of x minus e to the power of minus x is dt by dx, or dx is this side. So this is as simple as integration of 1 by t dt, which is log absolute t plus c. So if I simplify log of e to the power of x plus e to the power of minus x plus c, we know that this e to the power of x is always positive term, so you don't need actually absolute. Okay, modulus you don't require, so you can call this as log of e to the power of x plus e to the power of minus x plus constant. Yeah, this is also similar to that. You can use e to the power of 2x plus e to the power of minus 2x as t, then this is what you get dxt. Okay, so this is straightforward, you can do it yourself. Tan square 2x minus 1, so tan square theta, let's assume. Okay, so tan square theta, I'm writing it as secant square theta minus 1. So we know how to integrate secant square theta. Correct, secant square theta is nothing but tan theta, but here secant square theta has 2x minus 3, so x coefficient will become denominator. So 1 by 2 tan 2x minus 3, okay, minus integration of x, sorry, this is minus not plus. Okay, this is minus, so minus integration of 1 is nothing but x. Let's constant. Yeah, that's it. Next, secant square 7 minus 4x. Okay, we know secant square theta is tan theta, but here in theta place you have minus 4 as the quotient of x, so you will do you will take that into denominator, which is so minus 1 by 4 tan of 7 minus 4x plus constant. Sin inverse x divided by square root of 1 minus x square. We know sin inverse x, if I take it as t, then denominator goes into the dx, right? The denominator into dx is nothing but my dt. So this is as simple as integration of t dt, which is t square by 2. So t is nothing but sin inverse x. So sin inverse x whole square by 2 plus constant. Yeah, this one you look at this one. If I take 2 common, this is nothing but 3 cos x plus 2 sin x. Okay. So if I take this 3 cos x plus 2x as t, then I am getting numerator, that is minus 3 sin x plus 2 cos x, which is nothing but 2 cos x minus 3 sin x dx as dt. Okay, so 2 cos x minus x, which is numerator here, right? So this is nothing but uh, integration of dt by 2t, that's it. This is nothing but 1 by 2 log of absolute t, so 1 by 2 log of 3 cos x plus 2 sin x plus constant. So 1 by cos square x into 1 minus tan x whole square. We know that tan x integration is secant square x. This is secant square actually. 1 by cos square x is nothing but secant square. So take full 1 minus tan x is as t, then it is nothing but minus sin square x dx is dt. So my integration has become integration of sin square x divided by 1 minus tan x whole square dx, which is nothing but integration of minus dt by t square, that is 1 by t plus c constant. So 1 by 1 minus tan x plus constant. Yeah, here you take a square root of x as t, then you get everything in place. Okay, substitution. Okay, and here you know that if I take sin 2x as t, then cos 2x 2 cos 2x dx is dt. So I can replace cos 2x dx with dt and this with square root of t. Correct, and you will get a 1 by 1 by 2 term will get. Okay, so this is nothing but 1 by integration of t to the power of square root of t dt by 2, which is sin 2x whole to the power of 3 by 2 by 3 plus constant. Okay, cos x by square root of 1 plus sin x, which is almost same. You take 1 plus sin x as t, you will get cos x dx as dt. So this is nothing but integration of dt by square root of t, which is again 2 times 1 plus sin x whole to the power of 1 by 2. Yeah. Cot x log of sin x. So if I take log sin x as t, correct? Log sin x as t, then if I integrate it, I get cot x dx equal to dt. So cot x and dx will go into dt. So integration of cot x log of sin x dx is nothing but integration of t dt, which is t square by 2, that is log of sin x whole square by 2 plus constant. Okay. Sin x by 1 plus cos x, you can do it yourself. You take the denominator as t, then you get numerator will go into dt. Okay, you can do it. Only negative sign will come. Okay, carefully do it. This is also exactly same as above. Only thing is you will get, instead of 1 by t, you will get integration of 1 by t square. That's the only difference. Okay, rest all is same. Okay, next. Yeah, 1 by 1 plus cot x. Okay, this is slightly different. Okay, you expand cot x as cos x by sin x, then you will get sin x divided by sin x plus cos x. Okay, this I am rewriting this as 1 by 2 into 2 sin x by sin x plus cos x. Okay, so 2 sin x I am writing this as sin x plus cos x plus sin x minus cos x. Okay, so this expression, basically first thing I am doing is simplification using trigonometric methods first. Okay, so this is nothing but half into 1 plus sin x minus cos x by sin x plus cos x. Now I know how to do this part, right? This, if I apply integration, this is half integration of half dx, which is x by 2. Okay, then integration of this whole expression. So if I take this denominator as t, then numerator into dx is my dt. Correct? So denominator as t, then numerator, that is cos x minus sin x into dx, is dt. So if I substitute now, this is integration of half dx plus half into minus dt by t. Okay, this is nothing but x by 2 minus log absolute t by 2 plus constant. T is nothing but sin x plus cos x. I substitute it here. Okay, hope you understand how we have done this. Okay, so it involves trigonometric simplification plus integration. So most of the JEE problems you will get something like this. They will not give a problem from only one area of maths, right? They'll mix the things and give. So such problems you will definitely get. Okay. Yeah, 1 by 1 minus tan x, exactly same way you will do. Okay, previously how you have done, same way you will do it. Okay, this is the answer. Next, you can do it yourself, exactly same. Square root of tan x by sin x cos x. Okay, so now again do the simplification. Okay, this is nothing but sin x cos x. Okay, sin x cos x is nothing but, if I divide with cos x and multiply with cos x, this will become tan x into cos square x. Okay, so this is nothing but secant square x by square root of tan x, which we have done before. You take tan x as t, then secant square x dx is dt. So this integration is as good as integration of secant square x divided by square root of tan x dx, which is nothing but integration of dt by square root of t. That is this value here, which is 2 times square root of tan x plus c. Okay, next. 1 plus log x whole square by x. Okay, so we know that if I take 1 plus log x as t, okay, differentiation is 1 by x. Correct? So 1 plus log x as t, 1 by x dx is dt. So all my integration is simply integration of t square dt, which is t cube by 3, which is 1 plus log x whole cube by 3 plus constant. 1 plus x into x plus log x whole square by x. Okay, so here you look at this one. If I take x plus log x as t, okay, x plus log x as t, 1 plus 1 by x into dx is dt. This is nothing but x plus 1 by x, which is this part. Correct? So this is simple now. This is as good as t square dt actually. Okay, this turns into integration of t square dt, which is t cube by 3 plus c, that is x plus log x whole cube by 3 plus constant. X cube into sine of tan inverse of x to the power of 4 divided by 1 plus x to the power of 8. So the expression looks very complicated, but it is easy. Okay, you just keep trying. You can take x power 4 as t and then try. Okay, simply turns into, you take tan inverse of x power 4 as t. Okay, tan inverse of x power 4 as t, then this is nothing but, okay, this is nothing but 1 by theta square, that is x power 4, right? So 1 by 1 plus x to the power of 8 into 4x cube dx is dt. So only thing extra is here is 4, correct? So this is as good as x cube sine of tan inverse of x power 4 by 1 plus x power 8 is nothing but sine t, okay, by 4 dt. So sine theta, sine t dt divided by 4, which is nothing but minus 1 by 4 cos t, that is minus cos of tan inverse of x to the power of 4 by 4 plus constant. Okay, this is the 10 times x to the power of 9 plus 10 to the power of x log 10 divided by x to the power of 10 plus 10 times 10 to the power of x. So this is very clear, right? If you differentiate this, you get this numerator. So x to the power of 10 plus 10 to the power of x is t. So 10 times x to the power of 9 plus 10 to the power of x into log 10 into dx is dt. This is my dt, sorry, I missed here. Okay, so the integration is nothing but 1 by t dt, which is log of x to the power of 10 plus 10 to the power of x plus c. Okay, next. Dx by sine square x cos square x. Okay, so this is simplification is first. Okay, sine square x by cos square x, 1 by sine square x by cos square x. I can write this as sine square x plus cos square x by sine square x cos square x, which is nothing but secant square x plus cosecant square x. Now this is simple. Integration of this is tan x minus cot x plus constant. Yeah, in the as part of integration by substitution, actually wherever you get trigonometric functions and trigonometric equations, the best way is to use trigonometric identities, simplify the equation into either trigonometric or algebraic equations, and then solve the simple integration. Okay, this is there is a whole dedicated exercise for these trigonometric identities, actually using trigonometric identities. Why? Because this is a very common integration problem. Okay, wherever trigonometric formula are involved, actually you have to use your trigonometric knowledge, simplify it, and then solve the integration problem. Okay, some example will do. First, this is one of the very common example. Okay, sine 2x cos 3x. Okay, so you need to rewrite it into sine 2x and cos 3x is basically sine A, sine B. If I say this is in the form of sine A minus sine B, okay, and this is A plus B, sine A plus B minus sine A minus B, okay. So once you know this one, this is very simple, right? I will convert this integration of sine 2x cos 3x into half of sine 3x dx, integration of sine 3x dx minus half of integration of sine x, which is nothing but this value, right? So this is what substitution of trigonometric identity is helping, actually simplifying this into a simpler trigonometric formula to solve it. Okay. Another thing, sine cube x is there. Sine cube x, I can write it as 3 by 4 sine x minus 1 by 4 sine 3x. Correct. Once this is there, integration is very simple. Integration is just integration of sine x, integration of sine 3x. Correct. This the constant terms will be there anyway. So this is nothing but minus 3 by 4 cos x plus 1 by 12 cos 3x. Okay, this is nothing but minus 1 by 4 cos 3x divided by 3, which is 1 by 12 is coming. That's why. Okay, so this is how you solve. This whole exercise is dedicated for using trigonometric identities, simplifying, and then solving the problem. Okay, let's get into the exercise. 7.3. Yeah, sine square x. Okay, sine square some theta basically, right? So one thing you remember, not only in integration, even in algebra, wherever you see sine square x and cos square x, you have to check converting into cos 2x form basically. Okay, so cos 2x is nothing but 1 minus 2 sine square x. Okay, so sine square x is nothing but half of 1 minus cos 2x. Okay, similarly if it is given cos square also, you will do same. Okay, even in algebra also, wherever you see this, the best way to solve it is convert into cos 2x form and then solve it. Okay, so here also same thing will do. So this integration is nothing but half of integration of dx, because this is 1, minus integration of cos 2x, right? Double basically, that is 4x plus 10. Now this is simple. This is x by 2. This is x, actually x into 1 by 2, x by 2 minus 1 by 2 into sine 4x plus 10 divided by 4, because x quotient is 4 here, so 4 will come. So 4 into 2 is 8. Okay, so hope you understand how to use the trigonometric identities to simplify and then solve the integration. Okay, the next cos 3x, sin 3x, cos 4x. We have seen this in the example, actually, which is exactly same here. Half of sin a plus b plus sin a minus b. Okay, so this is nothing but half of sin 7x minus, because 3x minus 4x is minus x. Minus x means sin will become minus. Okay, so minus integration of sin x dx. So this is nothing but minus cos 7x divided by 14 plus cos x by 2 plus constant. Okay, now cos 2x, cos 4x, cos 6x dx, integration of this one. So formula I use is cos a into cos b is half of cos a plus b plus cos a minus b. I use this identity basically and simplify cos 6x and cos 2x basically. Okay, I'm using on this cos 6x plus cos 2x. Okay, sorry, first two. Sorry, cos 2x and cos 4x. I can write them into half of cos 4x plus 2x, which is 6x, cos 4x minus 2x, which is 2x, into cos 6x as is. Then this is nothing but, again I am simplifying using same identity, cos A into cos B, because this is cos 6x into cos 6x, which is nothing but cos 12x. Okay, then cos 2x plus cos 6x, which is nothing but 1 by 2 into 1 by 2, that is 1 by 4 cos 8x plus cos 4x. Okay, now this is a very simple form, right? Everything is in cos and one constant is there. So I'll get x by 4 plus sine 12x by 48 plus sine 8x by 32 plus sine 4x by 16 plus constant. Okay, next. Sine cube 2x plus 1, we have done in the example already. Okay, sine cube x, I can write it as 3 by 4 sine x minus 1 by 4 sine 3x. So in place of x, I have 2x plus 1. That's only difference. So I'll call this as, if I take 1 by 4 common, integration of 3 sine 2x plus 1 dx minus integration of sine 6x plus 3 dx, which I wrote the values here. Okay, this is the answer. Okay. Here, sine cube x, cos cube x. Okay, so obviously first thing I will do is sine x cos x is nothing but sine 2x by 2. Okay, sine 2x is 2 sine x cos x. So here sine x cos x is sine 2x by 2 whole cube. Okay, now this is sine cube x, correct? Sine cube theta. Basically, I will rewrite this as this same formula. Okay, so 1 by 2 cube is 1 by 8, 1 by 8 into 3 by 4 sine 2x minus 1 by 4 sine 6x. So now this is a simple trigonometric term for integration, right? If I integrate it, this is the answer you'll get. Okay, next. Sin x, sin 2x, sin 3x dx. Okay, I'll use this one. Sin A, sin B is nothing but half of minus cos A plus B plus cos A minus B. Okay, so I'm using it on the first two. So this will become half of minus cos 3x plus cos x into sin 3x. Okay, now I'm using cos x sin x, which is nothing but sin 2x, that is so it cos 3x sin 3x, which is nothing but sin 2x by 2, so minus 1 by 4 sin 6x by 2 plus again cos x into sin 3x, which I will rewrite this as 1 by 4 into sin 4x plus sin 2x. Okay, now once it is simplified, and then I can get the answer of integration, which is cos 6x by 24 minus cos 4x by 16 minus cos 2x by 8 plus constant. Sin 4x, sin 8x dx. So we have done this. Okay, so you can do it yourself. Next. Okay, integration of 1 minus cos x by 1 plus cos x dx. Okay, this one is, whenever you see this form, again you convert into 1 minus cos x you are seeing, 1 minus sin x you are seeing, convert into, I said, double half functions basically, right? You assume that this is cos 2 theta, correct? Then you convert into theta, cos theta. So in this case, 1 minus cos x is nothing but 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. So this is nothing but tan square x by 2. I can write this as secant square x by 2 minus 1. So I know, because secant square x by 2, I know integration easy. So this is the answer. Okay, once you know this one, you can do the integration yourself, right? So this is the one. Cos x by 1 plus cos x. Okay, so cos x, I will write it as 2 cos square x by 2 minus 1 divided by 1 plus cos x is nothing but 2 cos square x by 2. Now if I divide this numerator with the denominator, I get 1 minus half secant square x by 2. Now 1 I can do integration easily, secant square x by 2 also I can do integration easily. So this is the answer. Okay, next. Sine to the power of 4x. Okay, sine to the power of 4x, I can write it as sine square whole square. And I told you, whenever you say sine square x, you convert into double angle, that is 1 minus cos 2x by 2 whole square. Now this is nothing but, denominator is 4 and this one is 1 plus cos square 2x minus 2 cos 2x. Okay, now this is, if I simplify it further, this cos square 2x I again convert into cos 4x terms. This is what it is. Okay, so finally the simplification is 3 plus cos 4x minus cos 2x divided by 8. So this is simple, 1 by 8 integration of 3 plus cos 4x minus 4 cos 2x dx. Okay, that is the answer here. Okay, next. Cos to the power of 4 2x dx. Okay, almost similar to this one, not much different actually. So this I'll call it as cos square 2x whole square, which is nothing but 1 plus cos 4x by 2 whole square. Okay, and this I am expanding, 1 plus cos square 4x plus 2 cos 4x. I'm not going to touch this one. This is a simple integration. Only this one I need to worry. So I'll convert this again into cos 8x terms here. Okay, so finally I'll get is 3 plus cos 8x plus 4 cos 4x divided by 8. Okay, for that integration is here. This is the integration. Almost same problem as this. Okay, next. Sin square x by 1 plus cos x dx. Okay, sin square x, I'll write it as 1 minus cos square x and 1 plus cos x. So this is nothing but 1 plus cos x into 1 minus cos x. So divided by 1 plus cos x. So I'm left with 1 minus cos x. Now this is a simple trigonometric function for integration. That's nothing but x minus sin x plus constant. Okay, cos x minus sin x divided by 1 plus sin 2x. Okay, so yeah, this one you should have solved such trigonometric functions before, which is exactly same thing you will do. Cos x by sin x, I'll keep it as is, and I'll write this one as sin square x plus cos square x plus 2 sin x cos x. Now if you see, my denominator is nothing but sin x plus cos x whole square. Correct? So this is cos x minus sin x divided by cos x plus sin x whole square. Okay. Now see, now this is by substitution you can do. If I call cos x plus sin x as t, okay, then minus sin x plus cos x, that is nothing but cos x minus sin x into dx is dt, right? So I will do the substitution here. This is my integration. Okay, this is nothing but this integration of cos x minus sin x divided by cos x plus sin x whole square. Sorry, I missed here, whole square, which is equal to dt by t square, because this is cos x minus sin x dx is nothing but dt, and this is t square. So this is nothing but t to the power of minus 2 plus 1 divided by minus 2 plus 1, that is minus 1 by t plus constant, and the t is nothing but minus 1 by cos x plus sin x plus constant. Okay, so this is the, I am using both the trigonometric identity as well as substitution method of integration. Okay, so these are the kind of problems which you can expect. Okay, this is more or less, this is just a trigonometric identity I am using, nothing much actually. Right now there is no substitution I am using here till this part. Okay, next. Cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. So here you remember only x is the variable. Okay, cos 2 alpha and cos alpha are the constants. Okay, so remember that. So I'm writing this as cos 2x minus cos 2x. I'm writing it as 2 cos square x minus 1 minus 2 cos square alpha minus 1 divided by cos x minus cos alpha. So if I simplify this, 1 and 1 gets cancelled. I am left with the 2 times cos square x minus cos square alpha. I can write it as cos x plus cos alpha into cos x minus cos alpha. So cos x minus cos alpha in the denominator gets cancelled, and I'm left with 2 times cos x plus cos alpha. Okay, hope you understand how this has come. Now out of this also, remember, only this is the variable we can integrate. This is the constant term. Cos alpha is a constant. So integration of this one is nothing but 2 sin x plus 2x cos alpha plus c. Okay, next. Tan cube 2x into secant 2x dx. Okay, so tan cube theta, I will call it tan cube theta secant 2 theta is nothing but tan square x into tan 2x secant 2x. Okay, sorry, this is tan square 2x actually. Tan square 2x into tan 2x into secant 2x. Now I know that if I take secant 2x as t, correct? So this one I am writing it as secant square 2x minus 1. Tan square 2x I am writing it as secant square 2x minus 1. If I take secant 2x as t by substitution method, right? Then this is 2 times tan 2x secant 2x dx, which is dt. So this part will go off in dx. This gets converted into dt. So my integration is nothing but t square minus 1 dt by 2. That's all. This is half into t cube by 3 minus t plus constant, which is nothing but secant cube 2x divided by 6 minus half secant 2x plus constant. Tan to the power of 4x. Okay, which is nothing but tan square x into tan square x. Tan square x, I'll write it as secant square x minus 1 plus tan square x. So I can expand this into secant square x tan square x minus tan square x. Okay, so this I am writing it as secant square x minus 1 here. Okay, now I will use the substitution method. Okay, this is my integration, final integration. So I take tan x as t, then secant square x dx is dt. So I am left with, first part I am left with, okay, integration of t square minus dt, t square dt minus secant square x is nothing but t. So this is integration of t dt actually. Sorry, I made a mistake here. Integration of t dt. Okay, then integration of plus integration of dx or dt, you can call, right? So directly you can call it dx basically. Okay. So this is nothing but t cube by 3 minus, actually you'll get secant square x. I should get tan x actually. Okay. So yeah, this is the tan x. So this is the answer. Just do it yourself once again. Okay. This looks something I'm missing actually. I made some mistake in this. You can check it yourself. Okay. So this is how you'll do. Basically, translate tan power 4x into secant square x tan square x minus secant square x plus 1, and then use. See, this one is simple. This directly you can integrate. Correct. This is integration. If you do, you'll get tan x. Okay. This integration, how do? You take tan square x as tan x as t, then you will get secant square x dx as dt. So that's how you do it. Okay. Hope you understand. Next. Yeah. Sin cube x plus cos cube x divided by sin square x cos square x. Okay. So this one is simple. You expand it, sin cube x divided by denominator plus cos cube x divided by the denominator. Now this one I can write it as tan x secant x. This is cot x cosecant x. Now I know integration of this one very simple. This is secant x minus cosecant x plus constant. Okay. Similarly, if at all, whenever you see this form, okay, 1 by sine to the power of px cos to the power of qx, okay, right? Then you check what is the p plus q. P plus q is a negative even number. Okay, p means basically here, if it is in numerator, it will become sine to the power of minus px cos to the power of minus qx, correct? So p plus q is a negative even number, correct? In that case, then multiply and divide with secant to the power of n x, okay, where n is nothing but negative of p plus q. Okay, so in this case, p plus q is 4. So I am multiplying and dividing with secant to the power of 4x, because it is positive even number. So with the positive I am multiplying and dividing. Okay, so this is nothing but 1 by sin x cos cube x is nothing but secant to the power of 4x divided by sin x cos to the power of 3x secant to the power of 4x. If I simplify this, what is this? Is nothing but sin to the power of 4x by tan x. Okay. Now this is simple. If I take tan x as t, then secant square x dx is dt. Then this is nothing but secant square x dt. I am left with basically, correct? So secant square x is 1 plus t square, 1 plus tan square x, that is 1 plus t square dt divided by t, which is log t plus t square by 2 plus constant. So if I put t value back, then I get log of tan x plus tan square x by 2 plus constant. Cos 2x plus 2 sin square x divided by cos square x. This is a very simple expansion. Okay. So cos 2x I am writing it as 1 minus 2 sin square x plus 2 sin square x is there, gets cancelled. So I am left with only secant square x, which is simple. Next. Cos 2x by cos x plus sin x whole square. Cos 2x is, I can write it as cos square x minus sin square x. Correct? So I am left with cos x minus sin x by cos x plus sin x. So I take one of this denominator as t, then I'll get the numerator into dx is as dt. So this is nothing but integration of 1 by t dt, that is log t plus constant. So that is log of cos x plus sin x constant. Okay. So this one is such problems. What you have to do is x minus a minus x minus b is nothing but b minus a. So you multiply and divide with 1 by sine b minus a, and sine b minus a I am writing it as sine of x minus a minus x minus b. That's what I took actually, b minus a. Okay. Now if you expand and simplify, okay, this is what you get. You get 1 by sine b minus a integration of tan x minus a minus tan x minus b dx. Okay. Now I know what is the integration of tan x. Okay. Minus log of cos x minus a. Okay. So substituted here, and integration of tan x minus b is nothing but log of cos x minus b. Okay, then 1 minus b minus is as is. Okay, so this is what the answer is. Okay, if I simplify log a minus log b is nothing but log a by b, so I put in this format. Okay, next, sine inverse of cos x. Okay, now this is looks complex but very simple actually. Cos x I can write it as sine of pi by 2 minus x. So sine inverse and sine gets cancelled. I am left with pi by 2 minus x. So this is very simple. Next. Sin square x minus cos square x by sin square x into cos square x, which I will expand each fraction and then solve it. I'll get secant square x minus cosecant square x, which is nothing but tan x plus cot x plus constant. E to the power of x into 1 plus x divided by cos square e to the power of x into x. So if I take e to the power of x into x as t, then I'm left with e to the power of x plus e to the power of x plus x e to the power of x into x into dx as dt. So this is nothing but dt. This is cos square t. Cos square t is nothing but secant square t. 1 by cos square t is nothing but secant square t. So this is tan t plus constant. So tan of e to the power of x plus constant. Okay. And these are the some of the important integrals which you should remember. Okay. And the best way to remember is solve them yourself. Okay. If you solve them yourself, you will remember this. Okay. These are all important, and we will do one exercise just based on this. Okay. Based on this, we'll do one exercise. So I'll take just one of them. Let's take how you will get sine inverse x by a. Okay. So this is how you get it. Integration of dx divided by square root of a square minus x square. This, if I take x common, I am left with integration of dx by a times square root of 1 minus x by a whole square. Now I will take x by a as sin t. Then this is nothing but 1 by a dx equal to cos t dt. Integration of cos t dt divided by square root of 1 minus sin square t, which is t, because this is nothing but cos t. Cos t gets cancelled. Correct? So this is nothing but t plus constant, that is sin inverse of x by a plus constant. Okay. So derive all this formulae actually yourself, and then you will remember them easily. These are all very, very important integrals. Okay. Let's do some exercise based on this important integrals which we have learned just now. Okay. 3x square by x to the power of 6 plus 1. So first thing is convert it to a standard form. Okay, the standard form here is, yeah, you put x cube as t, then you will get 3x square dx as dt, then whole integration will become dx. Okay, a whole integration will become this form basically. Okay, integration of dx by x square plus a square, which is nothing but 1 by a tan inverse of x by a. So this will become, if x cube is t, 3x square dx is dt. So integration is nothing but dt by t square plus 1, which is in this form. Correct. So this is nothing but 1 by 1 into tan inverse of t by 1. If I substitute t as x cube, then it will become tan inverse of x cube plus constant. Okay, hope you understand how to solve this. First convert into one of the standard form and then substitute the formula. Okay. Now 1 by square root of 1 plus 4x square. Okay, first thing is you learn this is the one which we are going to use basically, because this is in this form. Okay, integration of dx by square root of x square plus a square is log of x plus square root of x square plus a square plus constant. Here 2x equal to t, if I substitute, then it will become dt by 2, dx is dt by 2. So the integration is nothing but integration of 1 by 2 square root of 1 plus t square dt. Okay. Then this is nothing but 1 by 2 into log of t plus square root of t square plus 1 plus constant. So if I substitute t equal to 2x, this will become 1 by 2 log of 2x plus square root of 4x square plus 1. Okay. So this is the integration. The third one is integration of 1 by square root of 2 minus x whole square plus 1. Let us assume that this is x. Then this is nothing but in the form of 1 by square root of x square plus a square, which is nothing but log of x plus square root of x square plus a square. So take 2 minus x as t. So minus dx is dt. So the integration becomes minus of dt by square root of t square plus 1, which is nothing but minus of log 2 minus x plus square root of 2 minus x whole square plus 1. Okay. So just remember, whatever you are converting finally here in this part x square root of x square plus a square, you will get same thing back. Okay. So remember that, that is, otherwise you may do some mistake. Okay. Next. Okay, integration of 1 by square root of 9 minus 5x square. You know, this is 3 square, this is 5x whole square. So take 5x as t, then this will become 5 times dx equal to dt. So my integration is 1 by 5. 1 by 5 integration of dt by square root of 3 square minus t square, which is in this form. Correct? Integration of dx by a square minus x square, which is sin inverse of x by a. So this is sin inverse of t by a. T is 5x. So sin inverse of 5x by 3 plus constant. Okay. Next, integration of 3x by 1 plus 2x to the power of 4. Okay. So take square root of 2x square. Basically, I am taking square of this whole thing. Okay. Square root of this whole thing. So square root of 2 by 2x square as t, then this will become 2 times square root of 2 root 2 x dx is equal to dt. So 3x dx is nothing but 3 dt by 2 root 2. Okay, so now I will just convert this into this form. Integration is nothing but 3 by 2 root 2. Integration of dt by 1 plus t square. This is in this form. Correct? Tan inverse x by a form. So the final answer is 1 by a, which is 3 by 2 root 2. A is 1 here, so no change. Tan inverse of root 2 x square plus constant. Okay, integration of x square by 1 minus x to the power of 6 dx. So take x cube as t, then you will get 3x square dx as dt. X square dx is dt by 3. So my integration is nothing but integration of 1 by 3 into 1 by 3 integration of dt by 1 minus t square. This I am applying this formula here. Okay, so the answer is 1 by 6 log of 1 plus 3x square by 1 minus 3x square plus constant. Integration of x minus 1 divided by square root of x square minus 1 dx. Okay, so first to split it. Okay, so I can split this as integration of x by square root of x square minus 1 dx minus integration of dx by square root of x square minus 1. This is straightforward, right? This is nothing but this formula here. Okay, where I'll just, the answer is the log of x plus square root of x square minus a square. A is 1, so I'll just put a as 1. This is the answer. Okay, this is second part. Integration of x by square root of x square minus 1 dx. I will take x square minus 1 as t, so it will become 2x dx equal to dt, which means this will become, whole integration will become half of dt by square root of t, which is nothing but square root of t plus c. Okay, if I do it here like this, you will get square root of t plus c. T is nothing but x square minus 1, so it is square root of x square minus 1 plus c. So whole integration is, okay, this part square root of x square minus 1 minus, because there is a minus here, right, minus log of x plus square root of x square minus 1 plus constant. Next, integration of x square by square root of x to the power of 6 plus a to the power of 6 dx. Okay, now I'll take x cube as t, so that it will become 3x square dx is dt. So x square dx, which is this part, is nothing but dt by 3. So my integration is 1 by 3 integration of dt by square root of t square plus a to the power of 6. Okay, careful, don't make it a square. That is the mistake you might do. Okay, so this is in this form. So if I apply, the answer is 1 by 3 log of x cube plus square root of x to the power of 6 plus a to the power of 6 plus constant. Secant square x divided by square root of tan square x plus 4. So obviously this is first to convert into a standard form, which is, if I take tan x as t, secant square x dx is dt. So integration is nothing but integration of dt by square root of t square plus 4, which is in this form. The answer is log of t plus square root of t square plus 4 plus constant. So if I substitute t equal to tan x, this will become log of tan x plus square root of tan square x plus 4 plus constant. Okay, now this is integration of 1 by square root of x square plus 2x plus 1. So first is convert into uh, x plus 1 whole square. This x square plus 2x plus 2, I can write it as x plus 1 whole square plus 1. So the integration is nothing but integration of dx divided by square root of x plus 1 whole square plus 1. Correct? This is in this form. So the answer is here. If I expand this x plus 1 whole square, the answer will come here. As I told, this part will remain same here. Okay, x square plus n square is same as this one. Actually, you are just changing it in this form, so finally you will get same here. Okay, so next, yeah, you can do this yourself. It is exactly same, only difference is there is no square root. So the integration you will get is integration of dx by x square plus a square, which is nothing but 1 by a tan inverse of x by a. So you will get answer as 1 by 6 tan inverse of 3x plus 1 by 2 plus constant. Okay, exactly same as before. Only thing is the formula you will apply is different, because there is no square root. Okay, square root of 1 by square root of integration of 1 by square root of 7 minus 6 minus x square. So similar to the previous one, only thing is you will get in the form of integration of dx divided by 4 square minus x plus 3 whole square, which is nothing but sine inverse of x by a formula. Okay, x is nothing but x plus 3, a is nothing but 4. So you will get answer sine inverse of x plus 3 by 4 plus constant. Okay, integration of 1 by square root of x minus 1 into x minus 2. First thing is you convert into a standard form, which is if you multiply x square minus 3x plus 2, which is nothing but x minus 3 by 2 whole square minus 1 by 4. Okay, now Once you know this one, this is the integration. Integration is nothing but integration of dx divided by square root of x minus 3 by 2 whole square minus 1 by 4. So this is in this form. If I substitute carefully, the answer is log of x minus 3 by 2 plus square root of x square minus 3x plus 2 plus constant. Okay, this is also exactly similar to this. I just convert this 8 plus 3x minus x square in this form. Nothing but 41 by 4 minus x minus 3 by 2 whole square. Okay, this is the form. So this is nothing but integration of dx by square root of a square minus x square, which is sine inverse of x by a plus constant. So I wrote here. This is the answer. Okay, next. Integration of 4x plus 1 divided by square root of 2x square plus x minus 3. This is straightforward. 2x, if I take 2x square plus x minus 3 as t, then 4x plus 1 into dx is dt. So this integration is nothing but integration of dt by square root of t. So answer is 2 square root of t plus c, which is here. This is the answer. Okay. Now this one we have solved the problem x minus 1 into x minus 2. Exactly same thing. Only difference is we are taking constants a and b. That's all. So this is a generic solution of what we solved before. Exactly same. You can follow the steps here. You can do it yourself. Integration of x plus 2 divided by x square minus 1, square root of x square minus 1. So I will write this as square root of x by, sorry, integration of x by square root of x square minus 1 dx plus 2 times integration of 1 by square root of x square minus 1 dx. Okay. Now the first one is, for the first one I'll take x square minus 1 as t. So x dx is dt. So this is nothing but 1 by 2, correct? 1 by 2 dt by square root of t, which is, this is the answer, square root of t, which is square root of x square minus 1 plus constant. Second part is straightforward. You will get 2 log x plus square root of x square minus 1 plus constant. So the whole answer is square root of x square minus 1 plus 2 times log of x plus square root of x square minus 1 plus constant. Yeah, from this question 18 onwards, you should definitely try it yourself every question. Okay, I will solve one or two here, but these questions are very important and you should solve it yourself. Okay, until unless you keep practicing these problems, you will not do it correctly. Okay, you may understand the method, but the final answer should be perfect and correct. For that, you have to solve this problem. So 18 onwards, you should solve every problem in this exercise. Okay. So how it is? This integration of 5x minus 2 divided by 3x square plus 2x plus 1 dx. How do you do this? This is nothing but I have to get differentiation of this one, correct? If I take this as t, correct? If I take this as t, dt is nothing but differentiation of this one, dx equal to dt, correct? Which means the differentiation of this should be expressed in this form. 5x minus should be expressed in the form of 5x minus 2 should be expressed in the form of differentiation of denominator, correct? Numerator should be expressed in the form of differentiation of denominator. That means what I am trying to do is I take two variables a and b. A times differentiation of denominator plus b is equal to numerator. Okay. Now simplify this one. Differentiation of this one is 3x square plus 2x plus 1 is nothing but 6x plus 2. So I will call a times 6x plus 2 plus b equal to 5x minus 2. So if I solve this one, very simple, right? X quotient is nothing but 6a. 6a is 5. So a is 5 by 6. And 2b is equal to, sorry, 2a plus b is equal to minus 2. So from that I will get my b. B is nothing but minus 11 by 3. So now I will write my 5x minus 2 in this form. 5 by 6, 6x plus 2 plus 11 by 3. Now my integration is, this one is nothing but I is equal to 5 by 6 integration of 6x plus 2 divided by 3x square plus 2x plus 1 dx minus 11 by 3. Okay. Sorry, b is minus actually. So minus 11 by 3 integration of 1 by 3x square plus 2x plus 1 dx. Now this is simple. If I take this is t, this is nothing but my 6x plus 2 dx is nothing but my dt. So this will become integration of 1 by t. Integration of 1 by t is, I know 5 by 6 is 5 by 6, same here. Log of t, t is nothing but 3x square plus 2x plus 1. So this is done. This part is done, right? Now I am left with second part. Okay, minus 11 by 3 times integration of this value. Now this one I will write it in this x square plus a square terms, correct? So if I write it, this is nothing but x square plus minus 11 by 9 integration of 1 by x plus 2 by 6 whole square plus square root of 2 by 3 whole square, right? So now I'm only doing this part because this part is done already. Okay. So this is in the form of 1 by x square plus a square, which is a by 2, 1 by a basically, right? 1 by a tan inverse of x by a, which is, so I'm writing it as minus 11 by a 3 by square root of 2 tan inverse of x plus 1 by 3, x plus 1 by 3, 2 by 6 is nothing but 1 by 3, right? X plus 1 by 3 divided by a, which is nothing but square root of 2 by 3. So if I simplify, this is what the answer is. Okay. So hope you understand how to do this problem. Expressing the denominator differentiation in terms of numerator. That is the most important step. Okay. Depending on what are the values of a and b you will get different integrations here. Need not be always same. Okay. You may get sine inverse, tan inverse, log, whatever. Right. So you have to solve every problem from here onwards. Okay. 18, 19, you do it yourself. Same thing. I am expressing denominator differentiation in terms of numerator. So I am getting here 6x plus 7 is nothing but 3 times 2x minus 3 plus 34. Okay, so that is this here. So if t I am taking this, then my dt is nothing but 2x minus 9dx. So I'll get, so here I am getting 1 by square root of t integration. Okay, so different integrations you will get, but the method is exactly same, and you will use your important integrals to substitute and then get the answer. Okay, so you can do it yourself. This is the answer. 20th also exactly same. Okay, you may get different integration formulas you have to apply, but procedure is exactly same. Okay, so do it yourself. This is the answer here. Okay, so this is also exactly same. I'm trying to solve it same way. Okay, representing the denominator differentiation in terms of numerator. That's it. That is the key idea here. Okay, rest all this procedure is exactly same. You may get different differentiation, as I said. So solve it. Again, same thing here. 22 also same. So you have to do these problems. Okay, because you may go some step wrong actually, and you may end up in a different differentiation. Okay, if instead of x square minus 6 here, basically x minus 1 whole square minus 6, if you make a mistake and make it plus, you end up in a different differentiation. Correct. So it is very, very important to solve these problems without mistake. Okay, again same. 23 also exactly same. Yeah, 24 is yeah, quite simple. Okay, just to take out of the these important things. This is a straightforward one. Denominator x square plus 2x plus 2 I am expressing as x plus 1 whole square plus 1. So this is nothing but uh, sorry, this is x plus 1 actually, not 2. X plus 1 whole square minus root 2 whole square. So this is nothing but my 1 by a tan inverse of x by a formula. So this is nothing but tan inverse of x plus 1. Okay, sorry, I think I did some mistake. This is not root 2. This is x. I think completely wrong. This is actually, this is not the one. Integration of 1 by x plus 1 whole square plus 1. X plus 1 whole square plus 1. Okay, that is what I should use here. So this is wrong actually. You can do it yourself. Okay, you will get the correct answer. Okay, so 25th is I express my 9x minus 4x square in this term. Okay, trying to convert into a standard form. The standard form I got here is 4 times 9 by 8 whole square minus x minus 9 by 8 whole square. This is in the form of a square minus x square. Correct, a square minus x square. 1 by square root of 4 is 1 by 2. So I am taking 1 by 2 out of integration. This is in the form of a square root of sorry, integration of dx divided by square root of a square minus x square, which is sine inverse of x by a. So my final answer is here. Okay, next. Yeah, and there is some this fractional rational functions, right? So you can reduce them using partial fractions. This you would have learned in algebra already. You have to apply the those whatever you learned there in this one. So if it is in the form of px plus q divided by x minus a into x minus b, where a is not equal to b, basically you will put that in the form of a by x by a plus b by x by b, and then solve for a and b. You will get values for integer values for a and b. So you can do it yourself. If it is in the form of px plus q divided by x minus a whole square, then you will equate it to a by x by a plus b by x minus a whole square, and then solve it for a and b, capital A and capital B. Similarly, other things. Okay, so these are the 5 very powerful algebraic functions where you will reduce it into partial fractions. Correct, in the form of partial fractions, and then solve the integration problem finally. Okay, so the next exercise is based on this one. Okay, the next exercise is based on these formulas. You will basically reduce the rational function into a partial fraction and then solve the problem. Okay, so let's do next exercise. Let's do some exercise based on partial fractions. Yeah, first one is integration of x by uh, x plus 1 into x plus 2. Okay, so by partial fractions we are trying to do. So we can do this, right? X by x plus 1 into x plus 2, I will write it as a by x plus 1 plus b by x plus 2. Okay, which means a plus b into x. Okay, that is x is equal to, okay, a into x plus 2. That means you will get ax plus bx. So a plus b into x plus 2a plus b equal to x, correct? So here very clear, 2a plus b is a constant term which is equal to 0. Okay, a plus b is quotient of x which is equal to 1. So from this I can derive what is my a and b. A is minus 1, b is 2, right? So I can write this expression back as integration of minus of 1 by x plus 1 plus 2 by x plus 2 dx, right? Now this is individually I can solve it. Log of minus log of x plus 1 plus 2 log of x plus 2 plus constant. Okay, so if I rewrite this 2, I will take it will become square and this will go to denominator, right? So log of x plus 2 whole square divided by x plus 1 plus constant. So this is how you solve the partial fractions problems. Okay, use the given fraction and derive partial fractions of that one, and then individually you can solve them. Most of them you will get in this form, so you will get log of this one, right? Okay, so next one. So 1 by x square minus 9. So previously we have solved this using 1 by x square minus a square, which is nothing but 1 by 2a, correct? 1 by 2a log of x minus a by x plus a, correct? So which is same actually. 1 by 2a, a is nothing but 3. So 1 by 2a is 6 log of x minus 3 by x plus 3, okay, because this is 3 square. But here, how we derived this formula is this is how we derived actually. Okay, I told you when I was doing this previous exercise, you derive all these important formulae. That is how you will remember. So this is how you will derive this 1 by x square minus a square. Okay, you can write it as 1 by x minus 3 into x plus 3, which is nothing but a by x minus 3 plus b by x plus 3. So same way as before, you will solve for a and b. A and b is nothing but 1 by 6 and minus 1 by 6. So I will write my integration as integration of 1 by 6 into 1 by x minus 3 minus 1 by x plus 3. This is, if I do the integration of by parts, basically this is what it is, 1 by 6 log of x minus 3 by x plus 3 plus constant. Okay, so this is the formula actually. If you remember, this is the formula you are supposed to remember. If you don't remember, it is not very complex to derive. This is how you derive it, okay, by partial fractions. Next. So most of the problems in this are mainly solving by partial fractions. So important thing is how you will get these partial fractions. Once you get that, it is mostly it is all same. You will get some log of some value. Okay. So here 3x minus 1 by x minus 1 into x minus 2 into x minus 3. I will write this as a by x minus 1 plus b by x minus 2 plus c by x minus 3. So I'll get a equation basically in terms of three variables. If I solve it, I get a equal to 1, b equal to minus 5, c equal to 4. So this is my partial fraction of the given integration. Now this is nothing but log of x minus 1 into x minus 3 whole power 4 divided by x minus 2 whole power 5. Okay, plus constant. Okay, similarly almost same as this one, but you have x there, but you will actually do it same way. Okay, you will get a different constant values, which is a equal to 1 by 2, b equal to minus 2, c equal to 3 by 2, and you will solve it same way. Okay, next. 2x by you will actually you will solve it in same way. Okay, so 2x by x square plus 3x plus 2, x square by 3x plus 2, I will write it as x plus 1 into x plus 2. So which is nothing but a by x plus 1 plus b by x plus 2. So I'll solve my a and b. A is minus 2, b is 4. So I'll get integration of this value, and this is the answer. Okay, 1 minus x square divided by x into 1 minus 2x dx. Okay, so this looks complex, right? So if you want to solve this one, you have to remember your partial fractions, all the ways how you actually solve the partial fractions. This is the very raw way, right? If you really can't solve it any other way, okay, this is the best way. You take the denominator, which is nothing but x minus 2x square, so or minus 2x square plus x basically. Okay, and the numerator is 1 minus x square. So 1 minus x square or minus x square plus 1, you divide with denominator. Then you get what is your quotient and remainder, right? So this is nothing but this is quotient, which is 1 by 2 plus remainder is 1 minus x by 2 divided by x into 1 minus 2x, right? Now this is your partial fraction here, right? You derived, and this one you can still do further. Okay, so how you can do is 1 minus x by 2 divided by x into 1 minus 2x is nothing but a by x plus b by 1 minus 2x, right? If you solve it, what you will get, a and b values, a is 1, b is 3 by 2. So my whole integration, this whole integration is nothing but integration of 1 by 2 dx integration plus integration of 1 by x dx plus 3 by 2 into integration of 1 by 1 minus 2x, right? So this is nothing but 1 by 2x, this is log x plus log x, this is nothing but minus 3 by 4 log of x minus 1 by 2. Okay, so this is how you do. I just took the minus out actually, that's why you got minus here. Okay, so this is my answer. Okay, plus constant term. Next. Okay, x by x minus 1 into x square plus 2. So whenever you see the power is more, okay, power is different from the numerator, highest power in a term. This is how you do basically. Okay, x by x minus 1 into x square plus 1 is nothing but ax plus b by x square plus 1, because this is x square power is there, right? So you should have at least x and constant. Okay, so ax plus b plus c by x minus 1. Okay, now you simplify this one, you will get again your a, b and c. C is half, which is same as b, and a is minus half. So you can separate your fraction into partial fractions like this and then solve it. Next, x by x minus 2 whole square into x plus 2. This how we will do is, which is nothing but a by x minus 1 plus b by x minus 1 whole square plus c by x plus 2. Now you will solve your ABC, which is C is minus 2 by 9, A is 2 by 9, and B is 1 by 3. Okay, so this is my partial fraction integration. This is the answer. Okay, next. 3x plus 5, integration of 3x plus 5 divided by x cube minus x square minus x plus 1. So we know that we can write this one, x square minus x cube minus x square minus x plus 1 as x minus 1 whole square into x plus 1. Okay, once you know this one, this is as simple as this one. I'll rewrite this as a by x minus 1 plus b by x minus 2 whole square plus c by x plus 1. Now you solve it. C is 1 by 2, a is minus 1 by 2, b is 4. This is your answer. Okay, next. This is also same as this one. Okay, you will just do it this way. X square minus 1, I am writing it as x minus 1 and x plus 1. Okay, so this is how it is. You can do it yourself. Yeah, this is also exactly similar. You can do it yourself, because x square minus 4, I will write it as x minus 2 into x plus 2. Okay, so you can do it yourself. Okay, this one, x cube plus x plus 1 divided by x square minus 1. Okay, so this one, if I divide, what I'll get is x plus, okay, use the long division method. Just now, one of the problem we have done. Okay, x plus 2x plus 1 by x square minus 1. So 2x plus 1 by x square minus 1, I will again divide into partial fractions like a by x minus 1 plus b by x plus 1. So my a, b are half and 3 by 2. So my integration is integration of x plus dx plus half into integration of dx divided by x minus 1 plus 3 by 2 into integration of dx by x plus 1. So this is the answer here. Okay. Okay, 2 by integration of 2 by 1 minus x into 1 plus x square. So we have solved this before. Since x square is there in the denominator, you will put bx plus c here. Okay, and then you will find ABC. A equal to b equal to all are 1 basically. So this is the answer. Okay, next. 3x minus 1 divided by x plus 2 whole square. So you can do multiple ways, but don't forget the easiest way. Okay, so that's why I just solved it in a different way. Take x plus 2 as t. So dx by dx is nothing but dt. So my 3x1 is nothing but 3t minus 7. Correct. So my integration will become 3t minus 7 by t square, which is nothing but 3 integration of 1 by t dt minus 7 integration of dt by t square. So this is how you can solve, or you can also call it a by x plus 2 plus b by x plus 2 whole square. You can solve that way. Find a and b, you can solve it that way also. Okay, next. 1 by x to the power of 4 minus 1. So I will write x to the power of 4 minus 1 as x square minus 1 into x square plus 1. So I can actually go ahead and do a by x minus 1 plus b by x minus x plus 1 plus cx plus d by x square plus 1. I can do that way also. This is the other way. 1 by, I will call y equal to x square. Then it will become 1 by y minus 1 into y plus 1. So this one I will solve using partial fractions, which is a is half and b is minus half. So it will become half of 1 by x square minus 1 minus half of 1 by x square plus 1. Now we know we have a standard formula for this one, right? So I just use the standard formula here and then solve the problem. Okay, next. Integration of 1 by x into x to the power of n plus 1. Okay, this is one variety of the problem given in this. Okay, normally all such problems, okay, wherever you are getting x to the power of n and denominator less than that, okay, you can do it this way. You take n into x to the power of n minus 1, which is differentiation of this, correct, x to the power of n. Okay, you multiply and divide numerator and denominator, or multiply and divide this fraction with n into x to the power of n minus 1. So given fraction will become n into x to the power of n minus 1 divided by n into x to the power of n into x to the power of n plus 1. Now you take x to the power of n as t, then your numerator is gone with the dx, it will turn into dt. So what your integration is simple, very simple, dt divided by nt into t plus 1. Now this one I will use my partial fractions. By looking at I can easily do it actually. 1 by n into integration of 1 by t into t plus 1, which is 1 by n into 1 minus t minus 1 by t plus 1, right? Partial fractions if I divide, this is what I get. Okay, this is simple. This is nothing but 1 by n into log t minus log of t plus 1 plus constant. So t if I replace, this is the answer. Okay, next. Okay, integration of cos x divided by 1 minus sin x into 2 minus sin x. So we know that we have seen sin x in the denominator, so obviously you will take sin x as t. So cos x dx is dt. So your numerator with dx is becoming dt, and the denominator you will have t terms. So my integration is nothing but integration of dt divided by 1 minus t into 2 minus t. Now this one I will solve using partial fractions as a by 1 minus t plus b by 2 minus t. Okay, so my AB are nothing but 1 and minus 1. So this is what, and this is the answer. Once I replace t with sin x, I get the final answer, which is log of 2 minus x divided by 1 minus x plus constant. Yeah, integration of x square plus 1 into x square plus 2 divided by x square plus 3 into x square plus 4. First thing is simplify it. Okay, so simplify, let's take x square as y, then it will become y plus 1 into y plus 2 divided by y plus 3 into y plus 4. Multiply numerator and denominator. So this is what it is. Now you do long division first, okay, because both are power 2, right? Both are of same polynomial degree. So you divide, do a long division, you will get 1 minus 4y plus 10 divided by y plus 3 into y plus 4. Okay, denominator is y plus 3 into y plus 4. We already know, right? Only for division, long division, you did this multiplication. Okay, now this one we can easily convert into partial fractions, right? So 1 minus this value into partial fractions, that is here. Okay, I am just calling this as a by y plus 3 plus b by y plus 4. So I get my a and b, and my partial fraction is here. So my whole integration is nothing but 1 plus 2 by x square plus 3 minus 6 by x square plus 4. I replaced y with x square again. Okay, now this is in the form of standard integrations which we know, correct? So integration is nothing but integration of 1 is x, integration of 2 by x square plus 3 is nothing but 2 by root 3 into tan inverse of x by square root of 3. Okay, minus 6 times tan inverse of x by 2. Okay, so this is the this is the final answer. Okay, yeah, next. Integration of 2x by x square plus 1 into x square plus 3. So we know that x square differentiation is 2x. So you take x square as t, so 2x dx is dt. So integration actually becomes integration of dt by t plus 1 into t plus 3. Now this I can do partial fraction. So I did partial fractions here. So this is nothing but integration of minus 1 by 2 into 1 by t plus 1 plus 1 by 2 into 1 by t plus 3 dt. So that one I wrote it here. Okay, and then replaced t with x square, which is nothing but final answer is half into log of x square plus 3 divided by x square plus 1 plus constant. Okay, integration of 1 by x into x to the power of 4 minus 1. So we saw this one problem, similar problem before. Whenever you find this one, you basically multiply with n into x to the power of n minus 1, which is highest power here is x to the power of 4. So you will multiply numerator and denominator with 4 into 4x cube basically. Okay, 4x cube. You multiply this with 4x cube. Okay, now you take x to the power of 4 as t. So 4x cube dx is dt. So my whole integration will become integration of dt by 4t into t minus 1. Now this one I can convert into a partial fraction. So 1 by 4 into, convert this into partial fractions, which is nothing but 1 by t minus 1 minus 1 by t dt. Okay. I just directly used because it is very simple, but you can use, if you don't understand, you can use this method, a by t plus b by t minus 1. You can do with that. Okay. So there's nothing but final answer is here. Okay, this is the answer. Next. Okay, 1 by e to the power of x minus 1. So I can write this as e to the power of x minus e to the power of x minus 1. So which is nothing but e to the power of x divided by e to the power of x minus 1 minus 1. Okay. So here I take e to the power of x as x minus 1 as t, then e to the power of x dx is dt. So this is same as basically integration of dt by t minus integration of 1 is x. Okay, plus constant. T is nothing but e to the power of x. So if I replace it, 1 by t is log x. So log t minus x plus constant. So log of e to the power of x minus 1 minus x plus 6. This is the answer. Okay. Yeah, this is a very straightforward and simple partial fraction which you can do it yourself. Cross check the answer. Yeah, this one is again you have to take in numerator and denominator. You should multiply with highest power of x, which is x square here. So n into x to the power of n minus 1, which is 2x, right? So multiply and divide with 2x, okay, and then take x square as t, then you get 2x dx is dt. So you are left with integration of dt by 2t into t plus 1. That is half into 1 by t into t plus 1. I can write this as, sorry, this is not 1 by 4, this is 1 by 2. Okay, so 1 by 2 into 1 by t minus 1 by t plus 1. So this is the answer. Okay, hope you understand how to solve this one. Next. Yeah, let's do one more method, integration by parts now. Okay, integration by parts you can understand this way. In differentiation, you have a formula. If f of x and g of x, product of f of x and g of x is there, and you want to apply differentiation. Okay, how do you do? If it is u and v, functions are u and v, then differentiation of uv is, or uv dash is nothing but u dash v plus uv dash. Correct? This is the differentiation formula for product of two functions. Okay, so for integration, how it is? Okay, we actually derive this one integration formula exactly from this one only. Okay, you can derive it yourself once. Okay, so this is how we do it. Integration of fx into gx dx is nothing but f of x integration of g of x dx minus integration of whole one, this one. Okay, this is completely under integration. Under integration, what is there? F dash x into integration of g of x dx dA, and then this one is whole integration dx. Okay, this is the formula you should remember very well. Now, one thing, what is similarity here? One is you need f of x. You need to identify what is your f of x. Then you need to do f dash x of that one. That is also required. Then you need integration of gx dx. Okay, and once you do it, you will use it 2 times. Then overall integration of this one. Okay. So let's do one example. If it is integration of x cos x dx, so I'll take f of x as x, g of x as cos x. Okay, so my f dash x is 1. Okay, and integration of cos x dx is sin x. Correct. Now I will replace this in the formula. So this is nothing but integration of x cos x dx is nothing but f of x into integration of gx. So that is 1 into sin x. So sorry, f of x, right? So x into sin x minus 1 into sin x dx. Okay, this is integration of 1 into sin x dx. That is integration of sin x. So overall the answer is x sin x plus cos x plus constant. Okay, now you can try this by exchanging f of x equal to cos x you take, g of x equal to x you take. Okay, you will end up in a cyclical way. You will keep doing integration again and again. You will not end up solving the integration problem by that. Okay, that means there is a priority of taking what should be my f of x. Correct? What should be my f of x is very, very important. Okay, so for that one there is one simple code is given, ILATE. Okay, ILATE rule we call it. Why it is ILATE rule? I is inverse trigonometry, L is logarithmic, A is algebraic functions, T is trigonometric, E is exponential. So whichever is coming first, you take that one as f of x. Okay, so in this case, this is algebraic, x is algebraic, cos x is trigonometric. So algebraic is above trigonometric, correct? So I will take algebraic as my f of x. In case it is cos x into e to the power of x, then I will take cos x as f of x. Okay, first function will be cos x in that case. So you hope you understand this one. This you need to remember ILATE rule. Okay, next. So let's do some problems based on this integration by parts actually. Okay, this whole exercise is almost all the problems are based on integration by parts. Okay, let's do it. So exercise 7.6. This is integration by parts, actually, exercise for. You have to solve all these problems because this is one of the most important formula in integration. Okay. So you have to solve all these exercise problems with NCERT book and then go for your other advanced books for JEE or BITSAT or any other entrance exam. Okay. Okay. Next. Integration of x sin x. It is exactly similar to the example you have seen because x is algebraic, sin x is trigonometric. This comes first. So f of x is x, g of x is sin x, and this is my formula here. Okay. For integration of f of x into g of x dx. So if I substitute go through this one, then it is minus, okay, x into minus cos x, which is minus x cos x minus integration of, okay, 1 into minus cos x dx. Okay, now if I integrate it further, minus x cos x and minus into minus plus sin x plus constant. Okay, hope you understand how to apply this as a formula. Okay, applying is very simple. Identifying what is your f of x is most important thing. Okay, you if you want, you can try reversing this one and try to solve it. Okay, you will understand the cyclical integration, which will stop you from finding the final answer. Okay, x sin 3x, which is exactly similar to this one, nothing different. F of x is x, g of x is sin 3x. So do the integration properly, substitute and do properly, you will get the answer. Okay, x square ex. Okay, so in ILATE algebraic is before exponential. Exponential is the last. So x square is my f of x. Okay, f of x is x square, g of x is e to the power of x. Now you substitute x square into e to the power of x minus integration of 2x. X square differentiation is 2x into integration of e to the power of x is e to the power of x. So integration of 2x e to the power of x dx. Okay, now this one again I will substitute same formula. Okay, I will take x as my f of x, e to the power of x as g of x, and then I get, so integration of x e to the power of x is nothing but x e to the power of x minus integration of e to the power of x dx, which is e to the power of x. So this is the, I'll substitute this value here. So overall my answer is x square e to the power of x minus 2 times x into e to the power of x minus 2 minus of minus, which will become plus. So plus 2 times e to the power of x plus constant. Okay, next. X log x logarithms ILATE logarithm is above algebraic, so I will take my f of x as log x, g of x as x. So first one is x into x square by 2 integration of x. This is minus integration of differentiation of log x is 1 by x into integration of x is x square by 2. So integration of 1 by x into x square by 2, which is nothing but integration of x by 2. Okay, so what I'll get finally is x square by 2 log x minus 1 by 4 x square plus constant. This is the answer. Okay, just a substitution into this formula, nothing much I have done. Okay, x square log x, again same thing, you will take f of x as log x because logarithmic comes above algebraic, and the g of x is x square. You will do exactly same. Okay, no different. Okay, you will get this final answer. X log 2x, again same thing, you can do it yourself. F of x is log 2x, g of x is x. Okay, so log 2x into x square by 2, okay, minus integration of 1 by 2x into x square by 2. So you will have this answer. Okay, exactly same. Next, integration of x sin inverse x. Okay, so in ILATE, I is in inverse trigonometric functions, so that is on the top most. So f of x is sin inverse x, g of x is x. Now how to solve this one? Okay, first is f of x into integration of g of x, so sin inverse x into x square by 2 integration of this one minus integration of differentiation of sin inverse x, which is 1 by square root of 1 minus x square into integration of g of x, which is x square by 2 dx. Okay, now this one we need to solve. Okay, so this one is simple. I take x as sin theta, then my dx is nothing but cos theta d theta. Correct. So I am left with this integration of x square by square root of 1 minus x square is nothing but sin square theta into cos theta by cos theta dt, which is nothing but sin square theta. Okay, sin square theta I can write it as 1 minus cos 2 theta by 2 d theta, which is nothing but 1 by 2 theta minus 1 by 4 sin 2 theta plus c. Now theta plus I will substitute sin inverse x. So the final answer of this one, okay, not final answer, answer of for integration of x square by square root of 1 minus x square is nothing but 1 by 2 sin inverse x minus 1 by 4 2x square root of 1 minus x square plus constant. Then I need to add this part, right, for the complete integration. So sin inverse of x into x square by 2 minus all this. Okay. So next. X tan inverse of x dx. Okay, again, inverse function is of highest priority, so tan inverse x is my I. Okay, sorry, f of x is tan inverse x and g of x is x. So I is nothing but tan inverse of x into x square by 2 minus half into integration of x square by 1 by x 1 x square by 1 plus x square dx. Okay, now I will take x as tan theta. So dx is secant square theta d theta. So my integration of x square by 1 plus x square is nothing but tan square theta into just integration of tan square theta dt. This I will write it as secant square theta minus 1. So answer is tan theta minus theta plus c. Okay, so this is my integration for the partial integration, which is x minus tan inverse of x, sorry, not theta, x plus c. So overall answer is nothing but tan inverse of x into x square by 2 minus half into x. Okay, minus into minus plus half into tan inverse of x plus c. Okay. Same, exactly same way you will do. You will take cos inverse x as f of x and g of x is x. Then you will get the answer. This is the answer here. Okay, you can do it yourself. Sin inverse of x whole square. Okay, very similar to the above problem. Only thing is first convert into, simplify this one first. Okay, you cannot take sin inverse of x into sin inverse of x and one is g of x, one is f of x. You cannot take. Okay, you will not, you will end up nowhere actually. You can try it. Okay, so take first x equal to sin theta. Okay, which means dx is cos theta d theta. So my sin inverse x is nothing but theta square into cos theta d theta. Now this is in the form of, this is algebraic, this is trigonometric. So algebraic comes first. So my f of x is theta square, g of x is cos theta. Solve it. You get some answer here, right? Theta square sin theta plus 2 theta cos theta minus 2 sin theta plus constant. Now theta is nothing but sin inverse x. So if I substitute, I'll get my sin inverse x whole square into x plus 2 times square root of 1 minus x square, which is cos theta, into sin inverse x minus 2x plus c. Okay, so this is what you get. Next. Yeah, integration of x cos inverse of x divided by 1 by x square. Okay, first thing is we need to convert into a form where we can do. Okay, right now we are doing the problems for integration by parts, right? So first thing is convert. Let's take cos inverse x is very hard in this, right? So take cos inverse x as theta, which means x is cos theta. Okay, so dx is nothing but minus sin theta d theta. Now you replace whole thing. Okay, so cos inverse x is theta, x is cos theta. Okay, then divided by 1 minus x square, 1 minus square root of 1 minus cos square theta into dx is nothing but minus sin theta d theta. If you simplify all this, what you are left with is minus integration of theta cos theta d theta. Now this is easy to do integration by parts. Theta as f of x, cos theta as g of x. Okay, then this is the answer you get. Replace theta with sin cos inverse of x. Then you get the answer. Okay, next. X secant square x. I think you can do this straightforward because you have value for integration of secant square x, right? Secant square x integration is possible. So you take x as, because algebraic is above trigonometric in ILATE, correct? So x is f of x, g of x is nothing but secant square x. Then we can straightforward, we will get the answer. Actually, substitute this into this equation, we will get the answer. Okay, next. Tan inverse of x. Okay, so this is very important integration. I think it looks like a standard formula how you are deriving, correct? So this is very tricky. Tan inverse of x integration actually. So here we call this as tan inverse of x into 1. Why? Because in ILATE, if you see, I is top, that is inverse trigonometric functions are on the top. So 1 I am considering as my g of x. Why I should consider 1 as g of x? If it is f of x, then f dash x is 0. Correct? If f of x is 1, f dash x is 0, then I don't get any useful thing out of it. Correct? So what I can do is basically tan inverse x I will take as f of x, because anyway inverse function is above algebraic functions. Okay? So my f of x is tan inverse x, g of x is 1. Okay? So if I apply into this one, then what it will become is integration of 1 is x. So tan inverse of x into x minus integration of differentiation of tan inverse of x is 1 by 1 plus x square then integration of 1 is x. So this is what I need to integrate now, right? This is simple. I have x square here, I have x dx here. So if I take 1 plus x square as t, 2x dx is dt, or x dx is dt by 2. So if I solve this one, I get 1 by 2 log t, which is nothing but 1 by 2 log of 1 plus x square plus constant, of course. So complete integration is nothing but x tan inverse of x minus half of log 1 plus x square plus constant. Okay, so this is a kind of standard formula. If you don't remember it, okay, but you should know how to derive it. Okay, and this is not very complex. Okay, it just takes 1 or 2 steps to solve this integration of tan inverse x. Okay, next. Integration of x log x whole square. So in logarithms is the in ILATE logarithm is above algebraic. So you take f of x as log x whole square, g of x as x. So in the first iteration you get log x whole square into x square by 2 minus integration of x log x you will get here. Okay, so x log x, again you apply this formula which I did here. Actually this is again I am applying this formula. You will get the complete integration. Okay, so the final answer is x square by 2 into log x whole square minus x square by 2 into log x plus x square by 4 plus constant. Next, integration of x square plus 1 log x, which is again similarly we will do. Log is above algebraic function, so f of x is log x, g of x is x square plus 1. So you will do same way, and you will again get a very simple algebraic integration here. Okay, which is nothing but x cube by 9 plus x you will get actually finally here. So my overall answer is here. Okay, this is my overall integration. Next, e to the power of x into sin x plus cos x dx. Okay, so this one you can do in multiple ways. One is if sin x equal to f of x, cos x is nothing but f dash x. So there is a formula for that. I will show you that in the next, but this one you can directly also solve. How you can do it? I'm expanding this one, integration of e to the power of x into sin x dx plus integration of e to the power of x cos x dx. Okay, now if I take this one, if I take this part, okay, where sin x is my f of x, e to the power of x is g of x, then it will, if I apply this formula, integration by parts, and only this one, okay, it will become sin x into e to the power of x minus integration of cos x into e to the power of x dx. Okay, now I am left with plus integration of ex into cos x dx. Okay, these two gets cancelled. I am left with sin x into e to the power of x plus constant. So this is the final answer. Okay, sin x into e to the power of x plus constant. This is the answer. Okay. So we can do this in using other formula which you can remember, because wherever you see e to the power of x, you can most of the times you can apply this formula. Okay, I'll show you how to do that. Okay, so in this one you can apply that integration of x into e to the power of x by 1 plus x square. Okay, now if I write this one, e to the power of x, if I remove this is x by 1 plus x whole square, so I can actually apply integration by partial fractions basically. So x by 1 plus x whole square, I am writing it as 1 by 1 plus x minus 1 by 1 plus x whole square. Okay, now this is nothing but e to the power of x is there already, so into. So now this is in the form of, okay, if I take this as f of x, 1 by 1 plus x as my f of x, then minus 1 by 1 plus x whole square is my f dash x. So this is in the form of integration of e to the power of x into f of x plus f dash x dx. Correct? This is nothing but e to the power of x into f of x plus constant. You may think how this has come. Okay, this is, if I differentiate this one, e to the power of x into f of x, what I will get? E to the power of x into f dash x plus e to the power of x into f of x, which is nothing but this. Correct? So this is exactly inverse differentiation function of this. So now I put my e to the power of x into f of x plus f dash x dx. Correct? So this is in the same form. So my answer is e to the power of x into f of x. So in this case it is e to the power of x into f of x is 1 by 1 plus x. So that's the answer. Okay. So you can solve many problems using this formula directly. Okay. This formula actually we derived in the previous question. Previous question actually we did same thing. Okay, this is what it is. Okay, if you see this one, this is f of x, then this is f dash x. Correct? So answer is e to the power of x into f of x. That's the answer. See. Okay, so you can solve many problems using this. Okay, this one also you can do it same way. Same, it is in the form of finally e to the power of x, you put it aside. Then this is nothing but 1 by 2 secant square x by 2 plus tan x by 2. So if you call this as a f of x, this is your f dash x. Okay. Sorry, if this is f of x, then this is your f dash x. Okay. So this is nothing but e to the power of x into f of x. So answer is e to the power of x into tan x by 2 plus constant. This is also exactly same. Straightforward, 1 by x is f of x minus 1 by x square is f dash x. So your answer is e to the power of x by x plus c. Okay, this is also similar. You can just first split this x by 3 divided by x minus 1 whole cube into two partial fractions like this, and then you can solve it. Okay, next. Yeah, e to the power of 2x into sin x dx. So we know that exponential is last, trigonometry is ILATE, t is before exponential. So f of x is sin x, my g of x is e to the power of 2x. So if I apply that, I get the answer, okay, in a two iterations. Okay, first iteration I'll get sin x into e to the power of 2x by 2 minus integration of cos x into e to the power of 2x minus 2 dx. Okay, now again I will apply same formula here, integration by parts I will apply. Then I get again sin x, integration of sin x into e to the power of 2x back actually, which is nothing but my I. Correct? This is my main integration. I will get this I by 4. So if I take it to other side, and then it will become 5 by 4i. So I will divide with everything with 5 by 4 here. Okay, this is the answer. Okay, this problem you should do it yourself. Important one. Some of them when you get cyclical integration, right? Cyclical integrations you get, this is how you'll solve it. This is a simple algebraic method actually. Okay, next. Integration of sin inverse of 2x by 1 plus x square dx. So we know that 2x by 1 plus x square, whenever you see, you should take x as tan x or x as tan theta. Then 2x by 1 plus x square is sin 2 theta. Correct? So my whole this expression is nothing but 2 theta actually. And dx is nothing but secant square theta d theta. So my integration will become integration of 2 theta into secant square theta d theta. Now my theta is f of x, secant square theta is g of x. So with that I'll get the answer straightforward. You substitute theta back, you'll get the answer. Okay, this is a straightforward method, x square e to the power of x cube. You take x cube as t. So 3x square dx is dt. Okay, so my integration is integration of dt by 3 into e to the power of t, which is e to the power of t by 3. T is nothing but x cube. So answer is e to the power of x cube by 3 plus constant. Okay, so this is again in the same in the form of integration of e to the power of x into f of x plus f dash x, which is answer is e to the power of x into f of x. So here f of x is secant theta. Okay, f dash x is secant theta tan theta. So my answer is e to the power of x into secant x plus constant. Yeah, some more ways of integration. Here if you see a quadratic equation in square root, basically, then you apply this formula. Okay, so these are very complex formulas if you look at actually. So it is very, very important to derive these formulas once yourself. Okay, you derive this one. Why? How come this has come? Okay, one simple example I'll give you. You can multiply and divide this with the same value here. So it will become a square minus x square by square root of a square minus x square. Separate, split it, two terms. Basically, each individual term you solve it, you will get this answer. Okay, straightforward. So that is how you can solve it. You have to solve this yourself to remember this, because sometimes you may not remember the formula exactly. So you should know how to solve it actually. Okay, not every formula you can remember, but with the practice, I'm sure if you practice 50 problems with this, you will definitely remember this formula. As you write, it will come in your pen. Okay, so all we have to do is now any problem, such problem comes basically in the form of either square root of a square minus x square, a square plus x square, or x square minus a square, it comes. Or if it is in the form of square root of ax square plus bx plus c, I basically convert them into one of this form, square root of m square plus or minus x square. Okay, or minus comes here also. Okay, minus m square plus or minus m square plus or minus x square. I'll convert and then see how I can solve this problem. Okay, so this 7.67 exercise is only about solving using this method. Okay, so it is a just straightforward method. You don't need to do much of calculation, but you have to remember the formula. That is important. So for this one, you have to solve this formula once. Okay, you derive it yourself, you will understand it. Okay, so integration of square root of 4 minus x square, which is nothing but square root of 2 square minus x square. So this is in this form, a square minus x square root of a square minus x square form. So answer is here. Just substitute the values. That's it. Okay. Next. Exactly same. It is in a square minus x square. So to get that one, what I will do is first I will take this coefficient out. Okay. Quotient out, I took 4, I took out. So square root of 4 is 2. So 2 is out. So this will become integration of square root of 1 by 4 minus x square. Now I will apply my formula here. Okay. 2 times this formula. This is the final answer then. Okay. Next. Square root of x square plus 4x plus 6. So I can write this as square root of x plus 2 whole square plus 2. So this is in the form of square root of a square plus x square. This is the integration. Okay, so I just substitute the values here. Here my x is x plus 2, a is 2. So this is the answer. Okay. Exactly same as before. Only thing is the formula I'll apply is square root of integration of square root of x square minus a square dx. Okay. This is also similar. I apply the formula for integration of square root of a square minus x square dx. Okay, which is here. This is also square root of x square minus a square dx form. Okay. Again, similar one. Okay, so I'm not just going into details of solving. It is as simple as you write the formula, you substitute values. That's it. Nothing else you need to do. Okay, so this is also similar. Yes, same again. Okay, this is the answer. Final answer is here actually for this ninth problem. Yeah, again same. Straightforward. 1 square plus x square square root of. Okay, so this one I am writing it in the form of square root of x minus 4 whole square minus 3 square dx. So formula I am applying this one. This is the answer. Okay. Yeah, that's all. These are the integration problems for indefinite integration. Integration is a very big chapter in NCERT. So I covered up to indefinite integration. I'll come up with a definite integration presentation also, and basic understanding of what is integration actually comes from there. Okay, integration is, as I said in the definition, is nothing but summation. Okay, that is most important thing you should remember. Okay, if I draw any arbitrary line in a graph, okay, the area under that curve is nothing but integration. Okay, so this you need to understand. So do more problems of integration and differentiation. That is how you can remember all the formulae. Okay, there are so many formulae. That's how you will remember. Okay, thank you.